How's it going? Right now, I am grinding off the copper surface off of pennies that are 1982 and newer because they stopped making them full of copper and started putting zinc in the inside of them. So right now I'm using 60 grit sandpaper to take off most of it, and then I'm going to use 400 grit to get it down to a smoother surface so we have a better contact area. Back here again in Boke's corner of the science world. So what we have done is taken off the copper off the one side of these pennies that have zinc in the inside because they did this to make them cheaper. And so now we have zinc exposed on the one side and copper on the other. And we have the aluminum, which will be the base of our circuit, and then we have our cardboard, which is soaking in vinegar. So we have our pennies that are sanded down on the one side. The copper is going to be our positive, and the zinc side is going to be our negative. And our cardboard is going to be our electrolyte because it's soaked in vinegar and it's acidic. We also have our tape, which we're going to wrap everything up together so it won't slide apart. We have our aluminum, which will be our base to help complete the circuit. And then we're going to power this little LED. So we're hoping to get enough voltage out of only 6 pennies that have been sanded, and if not, we'll go up to 8 and go up to 10 until we get this thing to be illuminated. So let's get together and start constructing this. Guys, we're back here. We finally got the cardboard and copper and zinc penny battery all reconstructed. And so, Kyle, go ahead and take it away.
All right, our battery's all set up, and each one of these copper and zinc cells with the cardboard is going to produce 0.8 of a volt, putting us at 6.4 volts. And let's see if it works. Works! Lighting up. I call that success.
Awesome. Okay, so the science behind this is that the pennies are the electrodes and the cardboard is the electrolyte. So when the LED is connected, it completes the circuit. And actually, the pennies, or this one isn't the copper isn't taken off the one side. The pennies that we've sanded down and exposed the zinc has started to change color because it's actually corroding or giving up.
We can actually see this right now.
Yeah, we'll show you. But it's actually giving up some of its ions to produce this electric current.
So if we look here, that used to be all nice and shiny, and now it's not, because stuff's plating onto it.
Physics.
So here we are, a week later. The LED is still on. So we're going to take it apart and see how the pennies look. Bo's going to tell you a little bit about the science behind it.
So what we found, we did a little bit more research in this last week, and we found that a battery is a package of one or more galvanic cells that is used for the production and storage of electrical energy by chemical means. A galvanic cell consists of at least 2.5 cells and a reduction cell and an oxidation cell. The chemical reactions in the 2.5 cells provide the energy for the galvanic cell operations. Each of the half cells consists of an electrode and an electrolyte solution, which the electrolyte solution was the vinegar, and the electrodes was the pennies that we took off the copper off the one side and exposed the zinc, and then left the copper on the other side of the penny. And the solution usually contains ions derived from the electrode by oxidation or reduction reaction.
Theoretically, vinegar is then our oxidation, or what is it? The fluid.
Or our fluid is our electrolyte.
Solution. That's it.
Yeah, it's our
it contains
electrolyte
our
solution.
ions.
Yeah. So Gunnar here is going to take it apart, and we're hoping to see some extensive corrosion, because on the first day after we had looked at it, we had already seen some plating of the different metals.
Hopefully these ones will be quite a bit more dramatic than that first 10-minute or so run.
Yeah, we were actually quite surprised. Me and Gunnar were talking in the morning, and he's like, yeah, it's still on, and we figured it wouldn't last more than probably a day.
Damn.
Wow. So there's quite a bit of plating on
They
this.
stuck together.
Yeah.
Damn.
Woo!
Yeah, that's serious.
Wow.
Well, I mean, that's the cardboard
Yeah.
peeling off.
But even the cardboard's like gone, isn't it?
Yeah. Here,
Yeah.
show it the camera.
Ugh.
So we got all sorts of white plating, which
Yeah,
product of the zinc plating onto the copper.
And it smells
I
too.
think so.
You smell that?
Yeah, I think that's the vinegar though that we're smelling.
Yeah.
Wow.
You can see all the zinc plated onto, or the copper plated onto the zinc.
So this is between the cardboard and a penny, and the penny is somewhat shiny, but the cardboard, from being the tan that it was, is now completely white. And then the other side of the penny, which was shiny where we had sanded it, is now black and
Blackish gray.
gray, and you can see where the wire was for the LED. That's where most of the plating is around it.
Yeah. Yeah, actually that's true. It does follow the wire.
Where was the, and this one was the other side, and you can see where the wire was on that one as well.
So what we have here, the product of this plating or this redox reaction, this is called our redox couple. And so, like a redox is the loss of the loss of electrons is oxidation, and the gain of electrons is reduction. And so here, this byproduct that we have from this chemical reaction that was going on between our electrode and our electrolyte, that formed a redox couple.
Oh, that one's got a lot of plating on it.
Oh, it's nasty. That one was doing some work. Huh. That's crazy.
Four times 2, 8 different pennies, and cardboard soaked cardboard in vinegar. Fuck! And here, Gunyar is now soaking vinegar. Fuck. Soaking cardboard in vinegar, which will help us create an acidic something and make power and blah blah blah.
It's called an electrolyte.
I like is that what it's called?
Electrolytic fluid.
Rondo.
It's
Rondo has electrolytes.
It's
It's not what plants.
Brondo!
It's got one plastic! Alright, go. Say what you said.
Right. Dude, you should totally say that. This cardboard has what plants crave. Electrolytes.
Brondo!
Does it really have electrolytes in it?
Yeah.
Oh.
It's
analytic.
And so the science behind it that we've found is that the pennies are the electrolytes and the cardboard is also the electrolyte. And so when the LED is connected to the circuit, it's completed. And that makes no fucking sense.
You just said it completely wrong.
Pennies are electrolyte or
Take a
electro.
screen
Oh, like, do we even know what the fuck's going on for this project?
You guys don't know the science behind it, dude.
We're making a fly stuff.
That was horrible.